G'day. Today we're going to exploit a game in bsdgames called Hack. It is an argv0 or program name stack-based buffer overflow. And we're going to write an exploit on 32-bit x86 with dep and ASLR, but no stack canaries. And we're going to use ROP to do that as well. So let's have a look at the game first. And the game is Hack. And if we look at HName contains our argv0 program name, and that comes directly from main, so it's our program name. This gets passed into a function called getHDate. So let's look at getHDate. Remember, name is our program name, our argv0 vector. There's this check here, this stat. So name effectively has to exist. So the program name has to exist as a file name or a path name of some kind, or a directory, for us to trigger this string copy here. Now the string copy assumes that file name is of max pathlen, and there's a couple of bugs here. Max pathlen might be different on different file systems, but this particular bug, it assumes that the arguments to the program, command line arguments, including the program name, are smaller than the max pathlen, which in fact they are not. So you get a string-based, stack-based buffer overflow, copying the program name into file name, which is on the stack and is 1024 bytes. So that's our buffer overflow. So let's build this code. It's sort of a convoluted way of building it, but it'll get there. And this is effectively making, we're sort of partially building it using configure and make to build the dependencies, and then we'll compile Hack manually as well. So it'll take a few seconds for this to run. We're in no rush. It'll just take a little bit longer. It's almost there. Almost there. There we go. So it's done that a little bit. It's created some header files here that we need. Let's move this make defs.c. Okay, now we're going to compile 32 bits, no stack canaries, no pi, link to the ncursors library. I'm going to write to the hack binary, a couple of includes. Okay, so there we go, executable. Let's copy this binary into our working directory. Okay, great. Let's just run, check that it runs. There we go. And we have the game playing. So we want to write an exploit now. We want to trigger this crash first. Let's open our exploit, our Python exploit. Import OS, import struct. We'll also use pwn tools for some of this. Okay, so let's prog name equals hack. We have our buffer equals program name okay. That looks okay. We might do one other thing as well. We're going to change the group of hack. I'll show you the original game actually. So we can see that game is set group ID to games. So this is actually a privileged program. So we're going to change the group of hack to games. And we're going to change mod group. So now we have our protections set up. So it's set group ID. The group is owned by games. There we go. Let's check our we get status of program name. So this is what we were sort of expecting. Can't get the status because it's doing that stat. So let's just go right into writing our exploit, and we'll work on it as we go. So we're going to create a pattern. Takes a few seconds to run. Let's just make sure we've got all of it. We do. Go to our exploit again. So let's create our cyclic pattern here. There we go. Now the thing is, we have to make program name a file or a path name that exists, or a directory that exists. It has to be a path name that exists. So we're going to do a few tricks here. Let's change this. Let's do I equals 100 while I is less than len buffer. Buffer I equals that. So creating a path name now. The important thing about this path name is that the subdirectories can't be they have to be quite small. So you can't just create a file of 2,000 bytes, because there are limitations on subdirectory sizes, which are much smaller than the max path len. So let's go into this. So let's add code to break this up into its subdirectories. And let's make a subdirectory. Okay. Need to change this back to a string now. Okay. Need to I have a problem with this. Let's okay. Let's do okay. So at this point, we should be able to get a crash, I believe. So let's see if we can run this. And we get a seg fault. Now let's just strace this as well. So you can actually see here it's doing that stat, and it succeeds, and then we get a seg fault. And actually we've got an address here. So let's do our core dumps. Oh, what am I doing? The problem with it not generating a core dump is because we have a set group ID. So let's change that for now. So on our exploit, we've got a core dump. So let's look at our core dump. There we go. So let's do pattern offset with our query. There we go. So we have an exact offset at 1045. That makes sense because our max path length is about 1024.25 bytes. It's okay. So let's replace this. Well, with something a bit. Okay, so let's do cyclic equals dot times 1 plus 1044. Buffer equals byte array cyclic. Okay, so we're up to our return address now. Let's do a classic return to libc. To start off with, you'll see why this doesn't work exactly as we want. Break at start, print system. It will also do find bin.sh in libc. Okay, so let's start making our there we go. Libc bin.sh equals struct pack little endian unsigned Okay, so let's do buffer plus equals libc system. We're going to have the return address after system exits here, and we'll just have a placeholder, and then our argument to system here. Now let's run this. Where are we? There we go. And we got a shell. Okay, and it seems easy, right? Game over, we've got a shell, but in fact, well, let's get rid of that core dump. Let's just run that again. We can run commands, and when we exit, we get a core dump. So let's fix that. Print exit. We'll do that. So let's chain our exploit to an exit call. Libc exit equals struct.pack. And where do we have exit here? Got our pop.eax ret, which will jump over this argument, and then we'll chain that to our libc exit, our return address after exit, which won't return, and then we'll have our argument to exit, which will just make -1. So let's run our exploit again. Oh, what have we got here again? Run our exploit, we've got a shell, we exit, and it seemed to have exited cleanly. There's some terminal issues as well, so let's run the exploit, reset, exit, we exit. Okay. Now the problem with this exploit, let's change our group ID, to make the binary set group ID. I'm going to sudo Silvio. I'm a non-privileged user now. Let's run our exploit. And I don't have privileges. I don't have privileges at all. So that's a problem. So what we're going to do is call set real and effective group ID with games as the GID to change our real and effective GIDs, and hopefully we'll maintain our privileges. And we're going to use ROP to do this. Let's go back into our exploit. Let's just get rid of that now. Okay. So we want to call set real and effective group ID before calling our bin sh. So first up, let's just find set real effective group ID, and we can see that the system call number is 71. Okay, so 71. Let's just check that our program is not privileged anymore. Great. We're going to set a breakpoint at start, run. So we need to build our ROP chain here. So the first thing we want to do is set EAX to 71. I'm going to call this system call. The arguments to the system call go into the registers. So we're going to use a different type of gadget that we haven't used in the past. We're going to use a negate. So let's do buffer plus equals. What we really want to do is neg EAX ret. Let's do a ROP search first. We've got heaps of these, so that's great. Neg EAX ret. And we're going to pass it negative 71. And we also need to, so what are we doing here? So we need to do our buffer pop EAX ret, buffer plus equals our negative 71. Then we call negate, and our EAX now has 71 ready for our set group and effective EID. Set real and effective EID. Now, what else can we do? We need to set EBX. Let's just look at our man page for set real and effective group ID. Takes two arguments. So EAX equals 71. EBX equals real group ID. ECX equals effective group ID. Then we do a system call. Then we do our system with bin sh. And that's effectively our exploit. Okay. So let's set EBX. We're going to set a breakpoint at start. We're going to search for a pop EBX ret in libc. Lots to choose from. Pop EBX ret equals struct.pack. Also going to search for an inc EBX. ebx ret struct.pack. Okay, so now we want to set ebx to group ID. So what is the group ID of games? So it's 60. So ebx is our, so we're going to do pop ebx ret. We're going to put a -1 . We have to be very careful here because we don't want to make this ROP chain too long. Now, one thing that we're going to do is add some forward slashes in here. So we're going to add inc ebx. We'll call that 6 times, and then we need something that we don't really want to, that we don't care about. And we're just going to add some slashes. Okay, so this is sort of a bit of a cheat's way of ensuring that we don't have our sub path name as too long, our subdirectory too long. Now let's do the same for ECX. Now there's a few ways we can do ECX and there's a few extra gadgets we can use, but we're going to do it like this. So let's see if we can pop ECX. We do have we do have that. Well, let's just take that one first. Inc ECX ret. We just have one. Okay. Pop ECX. So we do ECX 60 times. We need to add one extra as well here. Okay. Okay. Now we want to call a system call. So let's look at our syscall. So we'll call it here. We'll do it up here. libc syscall. Syscall, and we need to add 4 words, 4 D words. Okay. I think we've got our exploit. Let's just check it. So we've got our buffer. We set EAX correctly to 71. We set our group ID to 60 for real and effective. And the way we do that is we make EBX, for example, -1. We increment it by 1 to make it 0, and then we increment it 60 times to make it 60. I don't think we're even needing to use pwn tools at this point. Our exploit is working, probably going to work as is. So let's just try it. Who knows, it might work first time. I don't think it did work first time. Let's just trace it. So we called our set real and effective group ID. We absolutely called it. And we exited. Let's just check our code. Let's let's also make sure that ASLR is turned off. It should be. I mean, it wouldn't have been working otherwise. So we called our set group and effective 1, 2, 3, 4. Calling system, got our pop EAX, bin sh. Let's just check we've got the right address for system. For syscall, sorry. That looks good. Now I'm just going to make sure that our screen is set to the right. Does look okay. And we can still run it. Yes, absolutely. Have we got any bad characters in there? What is a slash? Should be okay. So we don't need. We make sure we've got no null characters in there. All looks pretty good. libc syscall, libc system. Got a bit of sh string. Why is it exiting? Let's run it again. Okay, so here we go. Default. So we have a bad address here. Let's just check that we found our binsh string. By F7 EC 9988. Default bad address. Let's just get a segfault. Get a core file. So it started it okay. We may have overwritten into the environment variables. So let's rewrite our exploit. Okay. So we're going to use another trick here to shorten the size of our shellcode, or of our ROP chain rather. We're going to look now for a ROP search for let's do an exchange, comma, x, comma, ECX. Okay, we've got an exchange here. Did we ECX EAX? Okay. Here we go. That looks pretty good. Okay. So we're going to set ECX using an exchange instruction, and we're going to save some size of our ROP chain. It does modify the EAX register, so we need to set it before, use this gadget before EAX is set. So let's do buffer plus equals, so we need to move pop EAX ret. Okay, now we're going to add struct.pack. We're going to make this -60. That's good. Okay. Now we're going to add a negate EAX to make it 60. Now we're going to add a call to this one here. Now this uses 3 extra registers, so let's pop 3 extra registers, so let's do that times 3, and now we set ECX to 60. Let's see how we go with that. Exploit. We got a shell. So so let's look at our ID, but we're not running as an unprivileged user yet. So let's just, we get a seg fault again because we removed that chain. So there are limitations to the size of the shellcode that we can use, or the size of our buffer that we can overflow. Now this might make it too long, so let's try that again. We got a shell. Okay, that's good. Now that, for people that aren't following along exactly why using this new gadget has resolved the problem that I had earlier, was that it's basically reduced the size of the buffer that we're writing to, the size of the data that we're overflowing this buffer with. So previously it was quite a long buffer. I mean, this is 10 of these, and that's 60 times 4, so 240, 244, 248. So this is about a buffer of about 3K, which is pretty long. And we've reduced that quite significantly now. Okay, so that worked. It exits cleanly, I believe. Let's just check that again. Exits cleanly. Now let's see to Silvio, an unprivileged user. Oh, I just have to make sure that this is privileged again. So an unprivileged user. Our privileged program. What am I doing? You can see the game works. Let's test our exploit. We've got a shell, and we have group ID games. So we have game privileges. It is actually a privilege escalation. Now let's do one more thing. Let's turn ASLR back on. sudo Silvio again, we'll see that our exploit doesn't work anymore. Doesn't work. Run it again. Segmentation fault. So let's write a little one-liner. And see if we can get a shell. Bit slow. I think it's because we're importing Pwn tools. Let's see if we can break out of that. So let's make that a bit faster. We didn't even use Pwn tools for any of this code. Fast, much faster. And then we got a shell. In 25 attempts we brute force ASLR and gained a shell. Awesome. So a little convoluted this this video. Certainly had a few problems with the size of the ROP chain, probably overflowing into the environment variables, overriding a pointer. What we could have done as well is pass null to our environment. Potentially that might have worked as well, but it might have caused problems with the game itself. Okay. So thanks very much for watching. If you want training in code review, reversing, exploit dev, interfacing with IT or ELF, go to the InfoSect Canberra website. Otherwise, if you want to be a Patreon pledger, go to Patreon. Thanks very much, and I'll see you guys next time.